In the realm of machine learning and natural language processing, the authors of this work introduce LitSearch, a novel retrieval benchmark. This benchmark comprises 597 realistic literature search queries, generated through a combination of two methods, using GPT-4 to generate questions based on paragraphs containing inline citations from research papers, and asking authors to manually write questions about their own papers. The authors extensively evaluate state-of-the-art retrieval models on LitSearch, including dense retrievers and BM25, revealing a significant performance gap between BM25 and dense retrievers, with a 24.8% difference in absolute. They also explored two language model-based re-ranking pipelines, which further improve the performance of the best-performing dense retriever by 4.4%. Additionally, they evaluate commercial search engines and research tools like Google Search, which perform poorly on LitSearch, lagging behind the best dense retriever by 32 points. LitSearch is designed to cater to a real-world use case, where researchers need to find literature related to specific search queries. The benchmark is constructed to require a deep understanding of research concepts and the ability to reason over entire articles. The authors argue that developing systems that can accurately recommend citations pertinent to such inquiries has the potential to enhance researchers' productivity and expedite scientific discovery. They also discuss the challenges of citation recommendation, which often requires deep domain expertise and reasoning through lengthy papers. The LitSearch dataset and code are made available at the authors provide examples of inline citation questions and author-written questions from LitSearch, which demonstrate the complexity and nuance of the queries. Overall, LitSearch is presented as an informative new testbed for retrieval systems, catering to a real-world use case and providing a challenging benchmark for evaluating the performance of retrieval models. The proposed research introduces a novel literature retrieval benchmark, LitSearch, which comprises two distinct subsets: inline citation questions and author-written questions. For inline citation questions, citation mentions are sampled from a collection of scientific papers and then rewritten into literature search questions using GPT-4. These questions are filtered based on word overlap with the target paper titles and undergo manual examination for quality. Additionally, authors of recent conference publications were invited to write literature search questions for their own papers. This results in the LitSearch dataset, containing 597 questions, each paired with one or more scientific papers as the ground truth. LitSearch is unique in featuring realistic literature search questions, posing a challenge to existing retrieval systems due to its depth and length requirements. This benchmark aims to improve the efficiency and accuracy of literature retrieval systems, making it easier for researchers to find relevant papers in their field. The authors of LitSearch describe their methodology for generating high-quality literature search questions by utilizing a large corpus of academic papers, S2ORC. They sample inline citation mentions, which are then rewritten into literature search questions using GPT-4. The questions are filtered to remove those with high word overlap with the target paper titles, ensuring they are not trivially answerable by simple keyword matching. The authors distinguish between ACL-sourced and non-ACL-sourced questions, depending on the source papers. They use in-context learning to prompt GPT-4 to generate questions based on sampled paragraphs and cited papers. The generated questions are filtered using a word overlap threshold to remove questions with high overlap with the target paper titles. Additionally, questions are collected directly from human annotators, specifically researchers who wrote papers in ACL 2023 and ICLR 2024 conferences. These authors were invited to write one literature search question for each of their papers, ensuring the correctness of the questions. The authors manually examine every question, annotating them for specificity and quality using the rubrics in Table 1. Questions that are too general or factually incorrect are excluded, and only questions with a quality score of 1 or 2 are included in the final dataset. The resulting dataset consists of literature search questions that are challenging yet meaningful, making them suitable for evaluating the performance of literature search models. The LitSearch dataset includes 597 questions, divided into two subsets: inline citation and author-written. The inline citation subset contains 351 questions, whereas the author-written subset comprises 246 questions. Notably, author-written questions are shorter and exhibit a higher word overlap rate with the target papers. The retrieval corpus, P, consists of ACL anthology and ICLR papers, totaling 64,183 documents. The average word count for titles and abstracts is 134, and for full texts, it's 6,041. The setup for comparing retrieval systems involves BM25 and state-of-the-art dense retrieval models, as well as LLM-BASED re-ranking strategies. The paper examines the performance of various retrieval models on the LitSearch benchmark, focusing on the use of titles and abstracts for retrieval and re-ranking. It reports recall metrics for broad and specific questions, highlighting the superiority of instruction fine-tuned embedding models like GRIT-LM7B. The authors also demonstrate the impact of re-ranking methods, including vanilla and one-hop re-ranking, which improve performance over base retrieval models. The results show a significant gap between GRIT-LM7B and other models, with improvements in recall metrics through re-ranking. The research paper discusses the development of a novel algorithm for optimizing complex systems. It starts by explaining the current limitations of existing algorithms and the need for a more efficient approach. The paper then presents the new algorithm, detailing its mathematical formulation and the underlying principles. The algorithm is tested on various real-world scenarios, demonstrating significant improvements in terms of computational time and accuracy. The study also highlights the potential applications of this algorithm in fields such as finance and logistics. This study investigates the efficacy of various retrieval models in citation recommendation, with a focus on performance differences between ACL and non-ACL sourced inline citation questions. Notably, one-hop re-ranking significantly enhances performance on ACL-sourced questions, but this improvement is less pronounced for non-ACL-sourced questions. This disparity may be attributed to BM25's ability to leverage the data annotation pipeline on ACL-sourced questions. In contrast, GRILM's initial top retrieval results already include the target papers, rendering one-hop re-ranking ineffective. Furthermore, the study benchmarks the performance of commercial search engines, including Google Search, Google Scholar, and Elicit, on a random subset of 80 specific questions. The results reveal that these search engines generally exhibit poor performance, particularly on inline citation questions. This underscores the potential of strong dense retrieval models for citation recommendation applications, where they can outperform commercial search engines. A novel retrieval benchmark, LitSearch, is introduced, comprising 597 manually curated literature search questions. These questions are divided into two sets: inline citation and author-written, both of which have undergone rigorous manual inspections. The authors conduct extensive experiments using BM25, state-of-the-art embedding models, and LLM re-ranking, demonstrating the superior performance of GRIT-LM7B on LitSearch. Specifically, GRIT-LM7B achieves scores of 42.0 for broad searches and 60.3 for specific searches. Notably, comparisons with existing retrieval benchmarks, including MSMARCO, CytoCS, and NQ, reveal that LitSearch is better suited to differentiate retriever models, providing an informative testbed that reflects recent advancements in embedding models. The paper also provides an overview of related work in citation recommendation and retrieval benchmarks, as well as the development and application of dense retrieval models in various tasks. The introduction of LitSearch aims to bridge the gap between existing benchmarks and the rapidly evolving landscape of retrieval models. The authors of the LitSearch dataset acknowledge its limitations, noting that some questions may be slightly out of distribution or too easy due to high overlap with target papers. They also recognize that author-written questions may not be as challenging as expected, even for experienced researchers. The evaluation was not exhaustive, and more sophisticated retrieval or re-ranking systems were not explored. The research focuses primarily on English questions and research papers, which may introduce biases in the dataset generation process. An ethics statement is provided, ensuring that the LitSearch dataset is manually inspected and free of unsafe or inappropriate content. However, potential biases are acknowledged, such as the inline citation questions containing more highly cited target papers and the author-written questions being limited to ACL 2023 and ICLR 2024 papers. The authors acknowledge the contributions of various individuals and organizations, including the Princeton NLP Group, ACL 2023 and ICLR 2024 authors, and funding agencies such as IBM and NSF. The page also includes a list of contributors and funding sources. Recent advancements in natural language processing have focused on citation recommendation and dense information retrieval. Contextualized models like BERT have improved citation recommendation by leveraging both local and global information. Dense information retrieval aims to directly answer user queries from a large corpus without relying on an intermediate step of retrieving relevant documents. Key papers include Context-Aware Citation Recommendation by He et al., which introduced a novel approach using contrastive learning, and Dense Passage Retrieval for Open Domain Question Answering by Karpukhin et al., demonstrating the effectiveness of dense retrieval techniques. Benchmarks and datasets like the Natural Questions dataset and the S2ORC corpus provide standardized evaluation for these models. Large language models like GPT-4 have shown promising results, and the KILT benchmark by Petroni et al. Evaluates knowledge-intensive language tasks. This overview highlights significant contributions in the field, emphasizing the need for more effective models and benchmarks to advance NLP capabilities. Research in text embeddings, information retrieval, and language models has yielded significant advancements. One notable study demonstrates the versatility of instruction fine-tuned text embeddings, showcasing their adaptability across diverse tasks. Large language models have been explored for their capabilities in search tasks, where they exhibit impressive performance as re-ranking agents. Furthermore, referral augmentation has been investigated as a means to achieve zero-shot information retrieval, eliminating the need for explicit training data. The BEIR benchmark has been established to evaluate the efficacy of information retrieval models, providing a standardized framework for assessment. Foundation language models have also been explored, with a focus on weakly supervised contrastive pre-training for text embeddings. This approach enables the learning of robust representations without relying on extensive labeled datasets. By leveraging weak supervision, these models can effectively capture semantic relationships and nuances in language, ultimately enhancing their performance in downstream tasks. These developments highlight the rapid progress in natural language processing, with significant implications for the development of more accurate and efficient language models and information retrieval systems. The authors of the paper acknowledge the significant contributions made by 246 annotators who provided author-written questions about their ACL 2023 and ICLR 2024 papers. This annotation process involved manual inspection of questions, with detailed instructions provided in Table 1. To recruit authors for this task, the researchers used email and Google Forms, employing templates found in Tables 10 and 11. This effort underscores the scale and complexity of the annotation process, demonstrating the importance of collaboration and community involvement in creating high-quality datasets. By recognizing the contributions of these individuals, the authors showcase their commitment to transparency and acknowledgement of effort. The annotation details reveal the meticulous methodology employed, highlighting the consistency achieved through standardized instructions and templates. This section serves as a testament to the collaborative nature of research, emphasizing the critical role that annotators play in creating valuable datasets. Developing a new challenging retrieval benchmark, LitSearch, is the primary focus of this research. This benchmark aims to evaluate the ability of large language models in retrieving relevant research papers given a research query. The corpus for this benchmark consists of ACL anthology and ICLR papers extracted from S2ORC. To identify these papers in S2ORC, the authors employ metadata and title matching techniques. The dense retrievers used in this study are listed in Table 9, including their Hugging Face checkpoint paths. These retrievers include GTRT5 large, Instructor XL, E5 large of 2, and Grid LM7B. The authors provide instructions for encoding queries and papers when using these models for retrieval. Additionally, the page presents the prompts used for generating inline citation questions via GPT-4, as well as the re-ranking prompt for GPT-4. Detailed statistics about LitSearch are also provided in Table 14. The authors also share an emailed template used to collect author-written questions for the benchmark. This template, shown in Table 10, is sent to ICLR 2024 and ACL 2023 authors, asking them to dedicate 2 minutes to write a literature search question about their paper. The authors assure contributors that they will be listed as contributors to the benchmark unless they prefer otherwise. Researchers are invited to contribute to the development of a challenging retrieval benchmark by crafting high-quality, literature search-type queries related to their own research papers. These queries should be realistic, specific, and challenging, aiming to create a dataset that can effectively test state-of-the-art retrieval systems. Guidelines for creating these queries emphasize specificity and challenge, such as reframing broad questions into more precise ones. For example, instead of asking, "What are some multimodal models?" one could ask, "Which multimodal model was the first to use interleaved image and text data?" Additionally, queries can be rephrased to reduce word overlap with the paper or focus on the main technique innovation, such as, "Is there any paper that combines distillation and structured pruning for language models?" Kofi pruning. The resulting dataset will be made available for open-source development, and contributors' names will be credited in the paper unless they opt out. This effort aims to create a valuable resource for researchers in related fields, providing a means to evaluate the effectiveness of retrieval systems and further advance the state-of-the-art in information retrieval. By leveraging the expertise of researchers in crafting challenging queries, this benchmark has the potential to drive innovation in retrieval systems and improve their performance in real-world applications. The authors argue that there are 2 primary motivations for the ad text generation task, particularly for product descriptions. From an application perspective, generating high-quality product descriptions can improve the seller experience for e-commerce services by reducing manual data entry and potentially increasing sales due to more attractive, structured, and persuasive descriptions. From a research perspective, ad text generation is an understudied task that serves as a suitable proxy for persuasive text generation, as cited in papers Cite_016, Cite_017, Cite_018, and Cite_019. The authors highlight that understanding persuasive text generation is crucial, and several papers have investigated this topic. For instance, papers Cite_016, Cite_017, Cite_018, and Cite_019 focus on quantifying the persuasiveness of text. Additionally, Cite_020 explores automating advertisement text generation specifically for fashion items, while Cite_021 presents a statistical framework for product description generation. Furthermore, Cite_022 generates persuasive text in Chinese for advertising purposes. The authors demonstrate a method for generating questions from inline citations using a language model, GPT-4, as shown in Table 12. This approach enables the creation of questions that cover multiple citations and are as detailed as possible. For example, questions can be asked about the persuasiveness of text, automated advertisement text generation, or generating persuasive text for specific domains. Overall, this page highlights the importance of ad text generation for e-commerce services and its connection to persuasive text generation, citing relevant papers in the field. LitSearch, a cutting-edge document retrieval and ranking tool, has been developed to enhance the precision and efficiency of research queries. By leveraging the capabilities of GPT-4, a large language model, LitSearch significantly outperforms traditional search engines and other document retrieval tools in terms of precision and recall. The tool employs a 2-step approach to document retrieval and ranking. Initially, it uses a broad search query to retrieve a large set of potentially relevant documents. Subsequently, it refines the search by employing a more specific search query to narrow down the list of documents to those most pertinent to the research question. Experiments conducted by the authors demonstrate the effectiveness of LitSearch, particularly when the search query is well defined and specific. The potential applications of LitSearch are diverse, including academic research, patent searching, and competitive intelligence gathering. However, the authors also highlight the limitations of the tool, such as its reliance on the quality and relevance of the documents indexed in its database and the potential for bias in the search results due to the use of a specific language model. In conclusion, LitSearch presents a powerful tool for document retrieval and ranking, leveraging the capabilities of large language models to provide precise and relevant search results. Its potential applications are diverse, and its limitations underscore the need for ongoing research and development to enhance its performance and mitigate potential biases.